Hey everybody, today we are starting unit number 8, which all revolves around gas laws. So for our gas laws, first I'm going to introduce the 4 different gas laws that we are going to discuss in this unit. We have Avogadro's law, which is right here, image that goes with it. We have Charles' law, this image goes with that, this graph. The graphs are going to be important. You can see volume and temperature are increasing together. Boyle's law, which is right here, revolves around pressure and volume. As volume is increasing, you can see that pressure is decreasing. Again, graphs are going to be valuable. And then we have Gay-Lussac's law, which is right here. You can see pressure and temperature are both increasing together. So these are the 4 gas laws that we are going to be discussing throughout this class or throughout this unit. Now, first, just some basic introductory items that we all need to know in order to properly execute our different gas laws. First, we have to know all of the variables that are involved with gas laws. And not all of them are going to be involved with every gas law we discuss, but you will need to know all of them when we get down to the ideal gas law, when we combine everything. So first we have pressure. P equals pressure, and routinely it's going to be measured in atmospheres. You'll see in the next slide sometimes that gets switched up a little bit, but pressure is measured in atmospheres, abbreviated ATM. Then we have V for volume. Volume is measured in liters, or L. N, something you haven't seen before. In our gas equations, N is going to represent the number of moles involved. So typically you would think that would say MOL or M, but in our gas equation, N is going to represent the number of moles. R is going to be our gas constant, and the gas constant is going to be the exact same number every time. That's why it's considered a constant. That number is going to be 8.31441 joules. So that is our gas constant, and when you see it in an equation, it will be represented as a capital R. And then we have T, which is temperature, and that is going to be measured in Kelvin. Now, if you have not heard of Kelvin, Kelvin is a temperature measurement used typically in science, and we will use either Fahrenheit or Celsius, in our daily life. And so one conversion that you will need to know is to convert from degrees Celsius into Kelvin. You just add 273. So whatever you have in Celsius, you add 273 to that in order to convert it to Kelvin. So an example right here: if you were given 20 degrees Celsius, you would simply add 273 plus 20 to convert to Kelvin. So 20 degrees Celsius equals 293 Kelvin. So that's pretty straightforward, but it is something you need to know because you'll see a lot of questions that are measured in Celsius. You have to convert that to Kelvin. That's among the first things you should do, is convert temperature to Kelvin, and you do that simply by adding 273. Now, another thing you'll hear about throughout our gas law discussion is standard temperature and pressure. Now, standard temperature and pressure is represented by the following values. So if you ever see STP, standard temperature and pressure, you know the following measurements. The standard temperature is 273 Kelvin, also 0 degrees Celsius. So that is our standard temperature, 273 Kelvin or 0 degrees Celsius. Our standard pressure is going to be 1 atmosphere. That's actually the pressure on Earth at sea level is 1 atmosphere. So that's just kind of an FYI there. The pressure on Earth at sea level is 1 atmosphere. So as you increase altitude or decrease altitude, your pressure will change, but we'll get into that. But standard temperature, 273 Kelvin, standard pressure, 1 atmosphere. And then the volume at standard temperature and pressure is going to be 22.4 liters. So you are going to need to be able to identify the temperature, pressure, and volume that exists at STP. And you'll hear me say STP a lot. That just represents standard temperature and pressure. So 273 Kelvin, 1 atmosphere, and 22.4 liters. Now, the one other thing that I wanted to introduce in our intro video to gas laws is how pressure can be measured. Now, if we look back here, I say that pressure is measured in atmospheres, which is typically the case. Every once in a while, pressure gets measured in a different way, though, and so we have to know how to convert back to atmospheres. So there's actually 3 ways that you can see pressure measured with reference to gases. You can see it in atmospheres, which is shortened ATM, and that's where we usually want it. You can see it measured in kilopascals, which is represented lowercase k, capital P, and then an A. And then you can see it represented in millimeters mercury, or mmHg. Those are the three ways pressure can be measured. Now, what we always want to try to do is convert pressure into atmospheres. Almost every single time we want to convert pressure into atmospheres. So the conversions that you need to know: 1 atmosphere is equal to 101.325 kilopascals. And then 1 atmosphere is equal to 760 millimeters mercury. So then obviously 760 millimeters mercury equals 101.325 kilopascals. But these are the two key ones you need to know right here. And you can just convert using dimensional analysis. And we'll practice conversions, but making sure you know 1 atmosphere equals 101.325 kilopascals, and then 1 atmosphere equals 760 millimeters of mercury. That's going to get us off to a good start. So we always want to measure, though. Always, most important thing, you always want to measure right there in atmospheres. Always, always, always want to measure in atmospheres. That's our most important thing. So these two conversions right here, excellent. Always want to look at those and then just use dimensional analysis to convert. But we'll do some practice problems later on. But that is our introduction to gas laws. So get ready to start talking about gas and their laws. Its laws. Farewell.